Hello friends and welcome at my channel. Today we're going to solve a few more limits with a trigonometrical function. I'm still not having enough of it and I hope you'll enjoy it with me. So the first limit is we're talking about the limit as x is running towards 0. We are handling x minus sine of x divided over x cubed. Alright? So if you look at this limit for the first time, you see, okay, at first sight you see x is running towards 0, so sine of x is also running towards 0. So the numerator is 0, the denominator is 0 as well. Well, normally, once again, you maybe would be doing L'Hopital, but I'm not doing it yet here. That's why we have to come up with a different idea. The trick, the so-called trick, I'm not even sure it is a trick, but we'll just switch, okay? We'll switch to 3y. You ask me why, and you'll see later on why we're doing this. So let's call x to be 3y. So as x is running towards 0, y is running towards 0 as well. We're not changing anything. So we're just writing actually limit 3y towards 0. I'm not changing really anything. 3y minus sine of 3y divided over 3y cubed. And you may ask me, why am I doing so? Well, you see, in my other playlist, trigonometry, I was preparing this, and I just today uploaded a video with the tripled angle. I'll link it right here, and you will see what I'm doing is basically applying one of the formulas of the tripled angle. So look at this. We're having limit, well, 3y still running towards 0. We're having 3y minus, and basically apply the formula. So this is, we have here 3 sine of y minus 4 sine cubed of y. And now we're dividing it over, well, we apply the power rules. We're having 27y cubed, all right? So is it a simplification? You may ask, what are you doing? We have just x to the power of 1 and sine of x to the power of 1 in the numerator, and we're having even cube power and so on now. So maybe it's not an improvement. Well, let's be just patient and see what's going on. So we have a limit. I still can write 3y towards 0. I can always switch to y towards 0 because as y is running towards 0, 3y is running towards 0 as well. But you will see it doesn't matter actually. So we are having 3y minus 3 sine of only y plus 4 sine cubed of y divided over 27y cubed. What are we doing now? We are separating the fractions. So we're having 3y divided over 27y cubed minus, we have 3 sine of y divided over 27y cubed, and we have 4 sine cubed of y divided over 27y cubed. Okay, so here we can cancel it easily. 3 and 27 are giving us 9. Y and y cubed are giving us y squared. We get 9 here. Well, let's keep it the way it is. So f a limit 3y towards 0 still. We have, well, basically 1 divided over 9y squared right here. We are having minus sine of y only, singular, divided over 9y cubed. And we are having 4, I'm not simplifying anything here, but I could write it as 4 divided by 27 times sine of y divided over y, this whole stuff cubed. All right? So I would like to simplify, to bring together the first and the second fraction. So maybe still let's not cancel any further. Let's multiply times y divided by y. because now we're having a limit 3y towards 0 of a y minus sine of y divided over 9y cubed. And let's separate it to the new limit, 4 divided by 27, limit 3y towards 0. And then we are having here sine of y divided over y to the power of 3. So what I'm doing, I'm splitting it. I can only split it if I can make sure that those two limits do exist. Do I know that? Well, this one is no problem, right? Because this is sine of y divided by y, as 3y is running towards 0, which means also y is running towards 0. So let me maybe rewrite it differently. Here, if I'm putting 1 divided by 9 towards the limit, and let's write it down as, instead of y towards 0, let's call it 3y towards 0. Let's call y towards 0. It's the same, right? Y minus sine of y divided over, well, just y cubed, and now plus 4 divided by 27. Because this is 1, if you remember, 1 cubed is still 1. So, now look at this. If I now consider the limit that I started with, this one, and the limit that I'm working with here, well, they're kind of the same. You see that? So we can bring it to the, we just can come back to x and y and z, it doesn't matter. This is just the same idea, okay? We have a variable and we have the same, exactly the same expression. We just have 1 divided by 9 here. So we're bringing to the left-hand side, and we're going to have limit x towards 0 of x minus sine of x divided by x cubed, and then minus 1 divided by 9 times the same limit. You see, if I'm switching back from x to y, or from y to x, it doesn't change the idea of the limit. So if you're, well, we can say you're switching x to 3y and then y back to x. You know what, for just the sake of argument, we can totally switch to z. Like, this is z, and we are not having changed anything, because from that point on, it's just about if 3y was approaching 0, y is approaching 0, right? So I'm not changing anything. So it's z minus sine of z divided over z cubed, and it's also the same here. And now you see, since it's the same, I can, so z minus sine of z divided by the z cubed. And on the right hand side, we just only have 4 divided by 27. So this is 8 divided by 9, the limit that we are looking for, divided over z cubed. And it's 4 divided by 27, so we're multiplying times 9 divided by 8, right? So the limit of z towards 0, z minus sine of z divided by z cubed, is equal to, well, it's not obvious, I guess. It's just 1 divided by 6. Are you kidding me? Well, seriously, I wouldn't expect it if I see it for the first time.